Hello everyone, I'm Xiao Gang. In this lesson, we're finally about to finish the last basic support, called the Smart Pointer library of this Unreal Engine. This Smart Pointer is very powerful, useful, simple, and also complex. If you've used the Smart Pointers from C++'s STD, they are essentially the same thing. It's mainly a process of reference counting. Before we begin practicing with the documentation, I'm afraid I've laid out so much for you. And then in the end, you tell me you didn't understand this chapter, then I would really feel too sorry about that. So let me tell you to what extent you need to master this chapter. That's enough at the very beginning. After you understand it, you only need to know how to use this struct. Just slip out and that's fine. Then the rest, how much you can grasp as much as you can, right? Then we give it a struct. Let's first write a smart pointer object. But actually declaring it like this is definitely not valid, not very complete, because we demonstrated it before. You can also publicly inherit one like this. Then we won't write it that way. Then we write out all the destructors. Okay, we don't need to include reflection info here for now. Then I'll add a log here for us. Then here we give it a name. Give it this, which is a leak. We'll still give it a destructor here. Okay, then we'll write a method here. This method will help us review the method we encountered earlier. Your inverse layer, Maya. SP struct. Good. Once we have a struct here, we can write it directly like this. GC to us. Then we need to pass a template. And this place is my smart struct. Then we have two ways. We'll just use one. There is a difference between the two ways. There's also make2 and make2. Generally speaking, you should use this one. Make C2 is better because there is a difference between them. Sometimes it comes up in interviews. I remember you should use MakeShare. Because their memory allocation methods are different, you can see from this comment. You can see MakeShare. It is noted. It is an excellent extension. It is excellent as a standard. An extension of an intelligent finger vibration. And MakeShare. It actually is. You can zoom in a bit. Zoom in a bit more. Let's print it out again. Let's just write 2. Write 2 like this. The way they are written is actually quite different. Look here. As for this thing, it allows them to explicitly convert text. This shared pointer, it is very, very useful. So when you need to use a shared pointer like this, it can be very useful. Look here. Here we need to look. And then we have another tip. Another one. We'll just write 2. And the difference between them is actually very simple. This way, you can see it like this. This way like this. And it says here that it returns you can see, it returns a shared pointer. Yes, it returns a shared pointer. And what it returns is actually, here's a reference. It is a shared reference. Then between the shared pointer and the shared reference, they have differences. We will check in the documentation later. And here it is with this thing, actually equivalent. And note that if this constructor parameter is private, then you may need to make a friend. Such a handling. Okay, good. This is the difference between the two. Then I remember the recommended line is using MakerSeries. Need to use it a bit more. Look, need to use it a bit more, roughly. Okay. then you only need to master up to this point. And after it goes out of scope, when all references to this object have disappeared after the reference count, this object will be demonstrated. Okay, then that's fine. Actually, here you can use a refy. Receiving should be possible. It should be like this. Okay, next let's take a look at our documentation. Look at our documentation. What is the Unreal Smart Pointer Library? It is actually a custom implementation by Unreal, built on top of C++11 smart pointers. It can reduce the burden of memory allocation and deallocation, and it follows industry standards for shared pointers, weak pointers, and unique pointers. It also adds a type called shared reference, and its reference behavior is actually the biggest difference is that it cannot be null, because a reference by definition must refer to an existing object, so it cannot be null, and because this set of it has created a separate memory tracking system. Its lifecycle is managed through smart pointers. Therefore, it has nothing to do with our UObject reflection. It is unrelated. Okay, everyone pay attention. It has nothing to do with the entire lifecycle of our UObject. It is unrelated. Different pointers have different ways of referencing the lifecycle of our objects. They are different. So let's take a look at which situations they are basically used for. First, the engineering pointer. It is the most commonly used. It owns the object it references. It can prevent the object from being deleted. Then, if there is none, if this project pointer, it serves as the last reference to that object. When it is deleted, it will also delete the object it points to. The project pointer can be null, meaning it does not have to reference this object. If it is not null, then it will increment the reference count of the object it points to by 1. And actually, we can use some methods to get its reference count. We can see that you can actually declare a shared here. This is completely fine. However, if you want to declare a shared reference, then declaring it in this way is completely infeasible. This way is wrong. We'll find that this cannot be done in this way, because a shared reference must point to such an object. And you can see that the shared reference is the same as a shared pointer. For null objects, it differs in form. A shared reference must reference an object, and the shared reference can be directly converted to a shared pointer, and both of them increase the reference count for the referenced object. Their technology is shared. That is to say, then, if you want to ensure that this object is definitely non-null, you'll need to use a shared reference. This is completely fine. Actually, we have some APIs here. You should see them in a moment. This light pointer, if we use it, you will see. Here it is converted into a shared reference. Yes, then here you can get this object. This releases the object. And these are some of its methods. Let me check. Let me see if there is a way to get this reference count. This reference counting technique. Let's take a look. This can be converted into weak pointers and shared pointers. It seems we can't quite get this reference counting technique. Let's see, this should be accessing its actual object. It must have a reference counting mechanism internally. Because regarding the shared pointer, you can check what the underlying implementation is. We won't discuss the underlying implementation here. And then, what is a weak pointer? Weak pointers are similar to shared pointers, but it does not increase the reference count, nor does it extend its life cycle. Affect its life cycle. Its only advantage is avoid this reference cycle. Then it can. That is, when he uses it, he should note that is because it does not affect the life cycle, but when it points to this object, when this object is destroyed, he will receive a warning. He will set himself to null. This is one of its biggest features when you use it. You can also convert it into this shared pointer. Then check if you can obtain it. That is to ensure it. That is, when I am retrieving it now, whether it is safe. Let me judge. I will take it and use it. If it is empty when I take it now, it means it has been recycled. Then I will no longer use it. Its biggest function is to break such circular references. For example, if a references B and then B references A, then now A and B, they cannot be destructed. Because for A to be destructed, B must be destructed first. For B to be destructed, A must be destructed first. So when two objects hold each other, then these two objects a memory. can never be released. So how do we handle this? At this point, we convert this reference relationship into a weak pointer. That is, we can know that the referenced object is this one, but we do not increase its reference count. It does not affect its lifecycle. As for unique pointers, at one, it means that only this one pointer exists. Once it undergoes a transfer, the ownership of this pointer is transferred. That is, no matter when or where, there is only this one pointer. It will explicitly use the object it references, and it cannot be shared. Then copying this pointer will cause an error, because here we can directly use the equal sign to copy, but this is not allowed. It will automatically transfer the permissions it holds. Then, when you use a unique pointer, you should not perform shared pointer or shared reference operations, because although doing so increases the reference count, the unique pointer is unique, which means when this pointer is destroyed, it will definitely release this resource. Therefore, unique pointers and shared pointers, shared references, are not interoperable or interchangeable. Generally, the first three are used together as a group, while the unique pointer is used as its own separate object. Now let's look at the benefits of smart pointers. The first benefit is preventing memory leaks. That is, once you have it out, you no longer need to worry about when to delete. You don't need to delete it, because it will delete itself for you. Then, for weak references, it breaks our loop reference cycle to prevent it from being normally garbage collected. And here, it is selectable. We can choose the smart pointer mode. It can be set to thread safe mode. Then you can manage reference counting across threads, right? The key point is this sentence: cross thread management of reference counting. Thread safe if thread safety is not needed, meaning I am very confident I wrote the code. It either runs in a single thread. The object of this reference will only be in this one thread. If you perform this kind of mutual copy transfer, then you don't need this lifetime pattern. Or you wrote multi-threaded code, although this pointer involves multi-threading. I can clearly know its lifetime. Then you can, to save performance, avoid using this thread safe pattern. Then share the reference. It is never null, and you can dereference it at any time. Then you can distinguish here who exactly is the owner and who is the observer. Then this is its memory. The size of the memory it occupies. It corresponds to this place. It actually has a dedicated byte reference controller. It itself occupies a size. Then the unique pointer is slightly different. It is largely the same as a C++ only. Then display provides some convenient and useful methods for you. Then displays TCR from S. Is when we define a structure, we define a parent class for it. This way, it can use some methods you can obtain, that is to say, when you inherit from this, then through this or this method, or some of its related objects, it's quite convenient for you to convert and access. Then we just demonstrated MakeShare and MakeShareable. And actually, MakeShare, this is one of its features, and we usually use MakeShare. It requires a public constructor, and MakeShareable. Its efficiency is lower, but it has an advantage. That is, the constructor can be accessed during runtime, and you can also customize some of these, define some behaviors we will see in a moment. And this is equivalent to doing a type conversion. That is our cost conversion. And this is actually a conversion from cost to cost. This is very similar to the standard behavior in C++11, and there are some details. We will briefly go over them. As for these details, actually, you can see that is because you have more features enabled. There will inevitably be some overhead. 勾以可物地. Its advantage is its computation, these constant times. Then, because it is at a high level, it is more suitable for use, because it encapsulates more information. But when it is closer to the lower level, in the relatively low level underlying implicit code, its usefulness may be limited. Then this thread safety, it is lock-free, because as long as we have threads, we emphasize being lock-free. Do not add this lock. Then you can safely proceed with copying such smart pointers. Then its drawback is it requires more computing cycles and some time and space overhead, and at the same time, it has two corresponding heaps. So we generally use MakeShared. Don't use make. This sometimes comes up in interview. This is considered a hit. Okay, good. Let's look at what an intrusive accessor is. Actually, this part is actually a bit complicated. But when we use it, we may need to convert this object, convert ourselves into the shared pointer, or just convert our own object into a shared pointer or a shared reference. So how do we do this? First, you need to make it inherit from tshared from this. Then you can convert it using a shared or shared this. Note that their representations are different. If you are the parent class, then the result is the same. So you can just do it like this. But if you inherit another layer, then your as shared returns the one inherited by your parent class, and shared this is the actual your own one. And here the class is written. This class requires you to pass in a subclass of fmac base class or a shared reference. So at this point, you need to do something like this. Then you can use these two methods must be used by inheriting from it. And here it is, an overridden method, right? So this overridden is actually a design pattern. Yes, a design pattern. It will pass in this object, and this object will then pass itself in. That is, passed in a registration of this kind. This factory approach is often used. It is frequently used. It might be a bit. That is, you need to know the difference between nshare and share. Their behavior is different in subclasses. Let's call this piece of code for everyone. Okay, all right. Then we'll port A to this position. And here we need to create its implementation. Actually, at this point, we might not really... This is just a common way of writing things in the engine. We need to paste it here. Let's take a look. Let me see if it compiles and check what the reason is. There are many errors here. Let's check them. It seems that this hook function is correct. Let's write the hook function. Of course, we need to make this constructor function virtual here. Then let's format it. Here is this. Then let's paste this down. Write it here as well. Let's check if there are still errors here. Let's see exactly which part has the problem. This place uses an undefined thing. This is quite troublesome. It might need to write the declaration position. Because it uses an undefined one here. Alright, now it compiles successfully. Let me show you. Let's move this thing up. Make two forward declarations. Then we add the public modifier. Then here we write the constructor. Then note the access level. We set it to public. Then the destructor here. There is a method here. Then this object needs to pass in a shared reference to it. So we make it nshare. You can see in share. That means you can access a shared reference to this object. Then this is, note this, it must be that this object has already been created for it to be useful. Then don't do this in the constructor of this object's constructor. You can see here, actually, in its documentation, it has already emphasized. Don't do this here. Call these unsales. CS because it requires this object to exist first before it can unshare. Or share. If you adjust it like this, it will trigger an assertion and crash because the access order is incorrect. Then in its derived class, since we directly inherit from it, after inheriting from it, this registrator also needs to pass a shared reference. When passing this shared reference, we need to use shared from it. You will find then shared from D is somewhere. It needs to go from this pointer to that is an actual appropriate reference. Okay, so basically that's roughly what this paragraph means. Then we can call the corresponding methods within this machine to implement some registration functionality. access its properties, that kind of thing. And you don't need to worry about this object being destroyed because it passes a shared reference. Within this scope, it is always valid if it goes beyond the scope and no other place holds its shared pointer. Then it will be destroyed. So that's roughly what this paragraph means. This will be asked in interviews, so everyone must keep it in mind when this projection. Actually, it's just a cast, so this part is very simple. A shared pointer is declared here. Then it is obtained through drag or drivement to get that shared pointer. And because, this shared pointer is actually one of these subjects, then you can perform a upcast or downcast. That's what it means. And usually, for upcasting, we can, of course, do it implicitly, right? Let's take a look. This should be a class within the engine. You will notice. It's right here, right? You will notice this is something within the engine that is often used for dragging a thing like this. This is a standard piece of code like this. Actually, in the RPG project, we also wrote it for you to implement a simple drag and drop like this. Then we can click into it and take a look at this drag and drop class. How does it work? T-shirt from this, right? No problem at all. Then we find this class. Find this class. This class would be related to assets. You can see it inherits from this detected drag top, and this inherits from decorates this drag top operation. So actually this is this kind of downcast, and then this smart pointer, it accesses in a single thread. It is basically safe. If you are dealing with multi-threading, then you should honestly just upgrade it to the multi-threaded version. And because this part involves multi-threading, it uses atomic reference counting, so it will be a bit slower. But all other behaviors are consistent. That is, reading and copying are thread safe, but writing and resetting must be equal to be safe. If you are sure you don't have multi-threading, then don't use this thread-safe version. Later we can demonstrate how to use it in multi-threading. Use this to intelligently specify the object to pass out data. Then here, that is to say, you need to avoid passing data, this kind of T2RFO, T2PDR to the function, because this will dereference. That is, because it will copy this pointer or convert this pointer. It will calculate and copy a temporary object, etc. Then pass it over and use it. It will repeatedly increase and decrease the reference count, although this will not cause changes to the data, but its reference count will increase and decrease, thus incurring overhead. At this point, we use this constant reference. Just use this constant reference for passing. Then you can declare this pointer as this incomplete type. And we have already emphasized to you the lifecycle of this UObject and the lifecycle of the shared pointer. They are different memory management. The two systems do not overlap. You should also be clear about this. Okay, so we briefly went over the document for you. Then next, we will go through them one by one. Alright, thank you everyone.